So in this first one, we have Juan and Maria are traveling to a concert. The trip takes 2 hours for Maria and 2.5 hours for Juan, since he lives 40 miles farther away. John travels 5 miles per hour faster than Maria, and we want to find their average rates. Well, what we're going to do is we're going to set up a system of equations. We're going to set up more than one equation, but I always do these in a table. And one thing we know about a situation like this is we know that the distance equals rate times time. And so what I typically do is I set up a column with time. Let me give myself a little space. A little column with time, and then a column with the rate, and then we're going to multiply those to find the distance. And what we do is one of the rows of our table will be for John's situation, and the other one will be for Maria's situation. First off, let's just kind of see what we can fill in into the table based on what's up here in the problem. It says the trip takes 2 hours for Maria. That means for Maria, her time is 2. And it takes 2.5 hours for Juan. Okay? So that's what we have from that sentence. We're able to fill in, okay, Maria's time was 2 hours, Juan's time was 2.5 hours. Now, we don't know how far Maria lives from the concert, but we know that John lives 40 miles further. So if the distance for Maria, if we just called that D, then we know that the distance for Juan is whatever Maria's distance is plus 40. Now what we don't know is their rates, but we are given a little clue. We're trying to find their rates, but it says that John travels 5 miles per hour faster than Maria. So once again, we're defining, just like we defined John's distance in terms of Maria's distance, we're going to find John's rate in terms of Maria's rate. So if we just call Maria's rate or speed R, we know that John travels 5 miles an hour faster. So for example, if Maria was traveling 60 miles an hour, he'd be 65 miles an hour, so on and so forth. Now, based on our equation up here, we said distance equals rate times time. That means I can come over to the right and write this out as an equation. We know that the distance for John is equal to his rate times his time. So his distance, which is, I'll come over here to the side, D plus 40 is equal to his rate times his time. And you can write that in whatever order you want, but it's just this times this equals this is the equation that we're setting up. Now, we have the same thing for Maria. Her equation looks a little simpler. Her distance is equal to her rate times 2. And so now we have our system of equations. From here, it doesn't really matter how you solve it, depending on how you've been taught to solve systems of equations. But what I'm going to do is I'm going to solve with substitution. In order to show you that, I'm going to go color-coded real quick. Let me rewrite Maria's equation in a different color. D equals 2R. What I can do is I can substitute that 2R in for D in the first equation. So let me kind of copy down what we have. We have R plus 5 times 2.5 equals D plus 40. And we can solve this little equation for R. And let's do that right now. So I'm going to distribute. I'm going to go ahead and I'm going to subtract 2.5R from each. Actually, let's subtract 2R from each side. Let's collect my 2R's over on the left side of the equation. So I have 0.5R, or a half R, plus 12.5 equals 40. And then I'm going to subtract 12.5 from each side. And so we have 0.5R equals 37.5. And I'm going to divide by 0.5 on each side. And that's going to give us our final answer, which is going to be 75. Now, we got to think about what that means. That means that we solve for R, the rate, which is 75, and it looks like we're in terms of miles per hour, okay? So that means Maria is traveling 70 miles per hour. So 75. So Maria is going 75 miles per hour, but we also know that John is traveling 5 miles per hour faster, so he must be traveling 80 miles per hour. So let's move on to our next example. It says Dorian gets to work in 20 minutes on most days. When he rides his bike, he goes the same route, but it takes him 45 minutes. His average driving speed is 4.5 miles per hour greater than his average speed on the bike. How far away is his work? So once again, we're going to use our idea that the distance is equal to the rate times the time. And now we don't have two different people like John and Maria. We just have Dorian driving and Dorian biking. So we have when Dorian drives and when Dorian bikes. And so I'm just going to set up my same little table and say the distance is equal to the rate times the time. And let's see what we can fill in. So as far as our distance, what we know is it's just him going to work, okay? It doesn't say it's longer one route than another way. It says he's going just the same distance every day, so I can just set D equal to D, okay? The distance when he drives and the distance when he bikes is the same. Now, we don't know, let's see what we know about his time. It says Dorian gets to work in 20 minutes most days, but when he rides his bike, he goes the same route, but it takes him 45 minutes. So when he drives, it takes him 20. When he bikes, it takes him 45. Now, we're going to come back to these in a minute, and you'll see why in just a second. But for now, let's leave it as that. His average driving speed, or his rate, is 4.5 miles per hour greater than his average speed on the bike. So it looks like we defined the driving speed in terms of the biking speed, because we said, oh, his driving speed is 4.5 miles per hour faster than his biking speed. Now, if we weren't careful, here's where we can make a pretty egregious error. It's that we would probably just start by trying to do distance equals rate times time and writing a couple equations. We have to be careful. Is our rate is in terms of miles per hour? But notice our time is in terms of minutes. So what I'm going to do is I'm going to rewrite this in terms of hours and this in terms of hours. And so hopefully you know that 20 minutes, that's a third of an hour, because 20 out of 60 minutes is 1/3. And 45 minutes, that's 3/4 of an hour, because 45 out of 60 is 3/4. Now what we can do is we can write our two equations. We know that the distance driving is equal to the rate times the time. If we're here, now we're ready to solve our system. We have two equations with the same variables. I'm going to go and solve with substitution, and what we can do is, since 3/4 r is equal to d, I can substitute it in for the d in the other equation. And so if I copy down what I have r plus 4.5 times a third is equal to 3/4 r. And now let's just solve with some algebra. I'm going to distribute, and I get a third r plus 1.5 equals 3/4 r. I'm going to try to collect my terms with r onto the same side of the equation, so I'm going to subtract a third r there, and I'm going to subtract a third r there, and I have 1.5 equals 3/4 r minus a third r. Now I'm going to run out of space, but it's okay. In order to subtract these two terms, I have to get a common denominator, and so what I'm going to do is I need to find the common denominator. In this case, it's going to be 12. Okay, 12 is the least common multiple of my denominators. And so in order to turn this into something with a denominator of 12, I'm going to multiply it by 3/3. And to turn this something into a denominator of 12, I'm going to multiply it by 4/4. I do that because multiplying by 4/4 is really just like multiplying by 1, so it's going to change the look of this number, but it won't change its actual value. So I have 1.5 equals 9/12r minus, and if I multiply this by 4/4, that would be minus 4/12r. Let's keep going. I'm going to come up here where I have some space, so 1.5 equals 9/12 minus 4/12 is 5/12 r. And then however you want to solve this is fine. I'm just going to maybe punch it into my calculator, dividing by 5/12 on each side. And let's see what that is. My rate is 3.6. Remember, that's in terms of miles per hour. So what we have is the rate riding the bike. So our bike rate is 3.6 miles per hour, but the drive rate is going to be whatever 3.6 plus 4.5 would be. I think that would be 8.1 miles per hour. So, but here's where we got to be careful. I almost moved on and ended this video, but this says, how far away is his work? Well, man, we did all this work to find the rate, but we don't know the distance. That's what we're actually looking for. Well, what we can do, now that I know that rate on the bike is 3.6, I know that the distance is equal to the rate times the time. So if I did 3.6 times 3/4, I get that the distance is actually equal to 2.7. If you weren't sure, you could check it up here, because you could do 8.1 times 1/3, and that should also give you a 2.7, and it does. So that was close. Our distance, our actual final answer is 2.7 miles.